Hello, this is Mr. McLeod, and I'm going to do a little demo on how to create a complete game in Greenfoot, including all of the things that you might run into, like how to import assets like images and sounds, and anything else that we might run into to make it go a little bit smoother and faster. Rather than spending a whole lot of time on the game design so that I can focus more on the implementation. I'm just going to take this old Scratch game that I made several years back, and I'm just going to translate this into a Greenfoot game so that basically all the game decisions have already been made, and so we know exactly what we're making. All right, so here's what the game is going to look like when we're done. So you're this thief, you've broken into this temple, and you're trying to collect all the treasure. Meanwhile, there's all these zombies, and they growl at you when they get close. Okay, and I'm gonna actually try to win the first time because it's a lot easier to lose than win. And then if I go over here, I can. Whoops! Whoa. You can see there. You can edge loop. Oh no, they got me. Okay. Well, let's try again. Okay, let's try here. Okay, this looks so pretty. Get all these things. Okay, come on. Here we go. Okay, get a whole row here. Whoa, that guy came the game out of nowhere. Okay, despite what it sometimes looks like, they're not actually trying to get to me. They're just kind of wandering around, and sometimes they trap me though. Okay, come on. Okay, here we go. I just got to get those last 4. And I win! Yay! Okay, so you pretty much, I think, seen what the game is supposed to look like. So let's go ahead and make it now. So I'm gonna close this, and we're gonna go over to Greenfoot. So let's open up Greenfoot first. Let's see. There we go. All right, so it's gonna have an empty scenario, and I want to make a scenario. So I'm gonna say new Java scenario. I'm gonna call this Lesson2Demo treasure grab. All right, and then notice you got to always pay attention to where it's saving so that you know where your project is. So I'm gonna save it in this same folder that I always have been making the demos in. But it's important that you know exactly where your projects are. All right, okay, and here we go. It's creating the project. So then what it's being, what it's doing under the hood, and I'm just gonna, let's see, I'm gonna move this down here. Okay, what it's doing under the hood is it created a project folder on the hard drive. So if I go back here, I'll see now there's my Lesson2Demo treasure grab, just like I told it to make. And then in here, there's this images folder and a sounds folder. This is where you're going to put your assets. So over here, I have another images folder somewhere else on my hard drive. I think it's on my desktop that has all of the images. So I can just select all of those, copy them, and then paste them into this images folder that's actually in my project. Okay, so that's why it's important to know where the project is so you know where the folder is with all the images that you should place the images in. Okay, and then somewhere here I also have sounds. Okay, here we go. So I'm going to copy all these sounds and also put them in the sounds folder in the project, right? Because just having some folder called sounds somewhere else in your hard drive doesn't do anything. It has to be the sounds folder that's actually in your project that you're working in. Okay, so now if I go back in here, I can start by setting the background for the world, can set that image to that cave stone floor. And so see now all the images that we had before that I just put in there are in here on the left side, right? Anything that's in the images folder. Okay, hit OK. And then I think you have to hit reset to reload the world, and then there it is. Okay, and then I'm actually going to make this world a little bit bigger. I want it to be 640 by 480. I'm going to do that. It's a nice size. Okay, and okay, so then in the actor class, so for actors, I need some actors to add here, and I'm going to start with the walls. So we're going to lay out those walls. So we'll make a new subclass, and I just select wall tile because that's what's available over here, right, for the walls. And I'm going to call this wall, hit OK, and now I could make walls. So to make the walls, I'm going to go over here into my world. And remember that in every program, the first thing that happens when you hit reset or when you load the project and it compiles it, is that the Greenfoot system creates an instance of your My World class, or whatever other, whatever world is first created by the project. In the project, that's the one that by default gets instantiated, and it does that by calling this constructor. So anything that you want to happen to set up the world should happen in this My World. Okay, I'm just cleaning up the curly braces because I like them like this, and I'm removing any extra comments because that way we can focus just on the comments that matter. Okay, so then in here, I'm going to lay out the walls. So the way that the walls are supposed to work out is we're trying to get, actually, let me do this. I'm going to share, do a new share of a whiteboard. So let's go to the whiteboard. Okay, so essentially, I'm looking to have, if this is my canvas, I'm looking to have all of these wall tiles are like laid out in squares like this, right? And they're either laid out vertically or horizontally, like so vertically in columns or horizontally in rows. And then there's like a gap in the middle. Okay, so they're kind of like this, right? I don't think I'm going to draw the whole thing. Okay, and then some of them are in rows like this. Okay, so essentially, if we were to make a method that drew rows of walls and another method that drew columns of walls, we could probably just use those two methods to draw all these walls. Okay, so let's go back to what we were doing here. Okay, and open up the My World class, and we're going to make some helper methods here. So we're going to call this public void because it doesn't do anything. I'm sorry, it doesn't return anything. It just does stuff. And then I'm going to call this draw row of walls. Okay, actually, you know what? I'm going to say draw horizontal wall. That's what I'll call it. Okay, and then let's do int x, int y, For this is going to represent the let's make it represent the upper left corner of the wall, of the leftmost wall. So let's define what we're doing here, and then I'm going to make a comment in just a second. And then int length is going to be like how many wall tiles is this, right? So let's explain up here in our description. We're going to say draw a length. Let's see. Draw a row, a horizontal row of wall tiles, length of the given length, starting with the upper left corner of the leftmost wall tile at XY. Okay. So now we have a good idea of what we're doing. So one of the reasons why I write this stuff out formally like this is that this way later when I'm doing later parts of the project, I can look at this and I understand exactly what this is supposed to do, right? Okay, so to do this, we need to make a for loop. So in the for loop, we're going to make length, right? This many wall tiles. So we can say int I equals 0, I less than length, I plus plus, so that our loop repeats length number of times. And then each time I need to make another wall, right? So we're going to say wall equals a new wall. And then this guarantees that we're making a new wall each iteration. If I were to take this and this is a common mistake that I see students do. If I were to type this up here, this would mean I'm going to make one wall, right? And then I don't know, in here, maybe I'm going to add it a bunch of times, but in the end, I've only made one wall. So the user is only going to see one little wall square, and the other ones aren't going to show up, right? Because there are no other ones. I've only said new wall once. That's how many instances of wall I've created. Okay, so instead, I want this to be inside the loop so that I make this many, right, length number of walls. Okay, and then each time I need to place the wall in the correct position. Okay, so to do that, I think we're gonna have to do some calculations to figure out where that correct position is. So let's draw a little picture of this. So if we're doing the horizontal one, then we want it to be, let's see, I'll do it right here. Actually, let's move this over a bit and I'll just do it over here so that there's room to write. Okay, so basically we want this to be laid out like that. Okay, it's good enough. And actually, wait, I feel like we should make it bigger so that we can label things more easily. Okay, 3 is probably good enough. Maybe 4. Okay, there we go. So just to clarify so that we know exactly what we're doing, in Greenfoot, when you place an actor at a position, what you're really doing is you're placing the center of the image at that position, right? So you could say that this is like the actual position that this that this wall is going to get placed at. So we could say this is like the next X, next Y. Okay. Maybe we should call it AX for like actor, or wait, well, WX, WY. There we go. Is that a little bit wider? Okay. So that's like the wall X, wall Y. Okay. But then the X and Y that we pass in the parameter is supposed to represent this X, Y. Okay. So we need to make sure we understand that. I'm going to put a star for that one. Okay. So we need to understand that because we need to make sure we get this in the right place. So the other thing that we need to know in order to lay these out next to each other like this is we need to have like the width of each of these squares, right? And we also need the height of each of these squares, which theoretically should be the same, right? Because they should be squares. But I'm just going to make it based on the actual image. Okay, so if we go here, we can say, okay, so before we get into the loop, it would be nice if we just figured out the width and height of the image of the wall, because we only really need to figure that out once, right? However, we just talked about why we don't actually want to write the new wall outside the loop for the walls that we're actually placing, because we need to actually make this many walls. However, what we could do up here is we could make what I like to call a model, right? So we're going to basically make a wall, and the only purpose of that wall is to act like a model so that we can ask it for its width and height, right? So we're going to say wall, and I'm going to call this model equals a new wall, and we're going to use that to get its dimensions. And if you remember, in Greenfoot, actors do not actually have a width and height. They have an image that's associated with them, and the image has a width and height. And this is important because actually the image that an actor has could in fact change from time to time, right? So that's why it's important that it's the image that has the width and height, not the actor. Okay, so that would mean that in here, if we want to get the wall width, we're going to have to say first, we need to ask the model, okay, for its image. So I can call get image on the model, okay. So now I have a Greenfoot image, and then dot. Now on that image, I want to call get width, okay. So I got the image of the model, and then I called get width to get the width of that image, okay. And then I'm gonna do the same thing for the height. I can say int wall height equals model dot get image dot get height. Okay. So essentially that's going to be our W and our H here. All right. So then to place the first square, I need to go over half the width and down half the height, right? So I'm actually going to make a variable that is going to represent like the next, the wall at WX and WY, because then my plan here is to start out with WX, WY here, and then every iteration, I can just change WX, right? Because WY stays the same. I can just change WX by the wall width, and it'll just get to the next WX. Okay, so I'm going to initialize WX to the X position of the upper left corner plus half the wall width. Okay, and then WY is going to be the Y position plus wall height divided by 2. So Greenfoot, the X is positive this way, negative this way, and the Y axis is flipped compared to mathematics. So up is negative and down is positive. So if you were wondering, that's why it's plus wall height over 2. Okay. So then back here, all I need to do now is just add the wall to the world. So when you're adding the wall to the world, it's the world class. If you look in the API here, you'll see that it's the world class that has an add object method that takes the actor that you would like to add, and then the X and the Y where you'd like to add it, right? So let's go back here. And if you look in the class that we're working in right now, we are in the My World class, which extends world, which means that My World is a subclass of world, and therefore it inherits all these methods from the world, okay? So the object that I would like to call get add object on is the world that is running this code right now. So you can access that object by saying this. So I could either say this dot add object, okay, or if I just say add object, that's the same as saying this dot add object. Okay, so you need to be aware of that, because if you ever just say a method name, if you're just saying a method name for an instance method, that means you are saying you want to call that method on this, where this is the instance of the class that you're in. Okay, and specifically it's the instance that's running this method that you're working in. Okay, so somewhere, when this runs, draw horizontal wall has to be called on a my world, okay, which that whatever my world that is, that's this, okay. All right, so we can just say add object, and then we pass it the wall that we want to add. We want to add the wall that we just created here, okay, not our model, because the model would be the same wall every time, whereas this is a different wall every iteration, right? Because each iteration we say new wall, okay. And so then we want to add it at the WX wall X, right, and WY is the wall Y, okay. And then after we've added that wall, we need to update the wall X to be the next X position, right? So we need to add the wall width so that we shift over to the right by wall width. Okay, so I can say whoops, don't redeclare it. You say WX plus equals the wall width. Okay, so then this will change, this will increase WX by wall width. Okay, so let's actually do a test run here just to like confirm that this works the way we want it. And we might as well draw it in a place where we actually want one of the walls. So let's go back here to the main world here. So this world is all the way across here is 640, right? And I happen to know that that these wall images are each 64 by 64. So if I were to draw, so that would mean 10 of them would fit across, right? So if I want 2 in the middle that are open, then that would mean that would leave 8. So if I made it 4 here and 4 here, then I'd have 2 in the middle, and that would make the layout that I want. Okay, so that means the one I'm going to test on first is 0, 0, right? So we want the upper left corner to be right here at 0, 0. Oops. Okay, right here. So let's do that. Okay, so back here, whoops, go to mouse, clear that. Okay, so my world, in the constructor, I need to call this method, draw horizontal wall, and I'm going to pass it 0, 0, and 4. Okay, let's try that. Oh, there we go. Oh, holy smokes! These images are twice as big as really what I want. I think I want them to actually be 32 by 32. So there's a couple ways that you could do this. You could open up a graphics editor and change the actual size of the image, or we could just go into the wall class and just ensure that it's the size we want. I think I'm going to go that way because I think that'll be a good thing for you guys to see here. So I'm going to delete all these extra comments, kind of clean this up a little so that we can get started here. Okay, so in the actor class, what they've written for you already is the act method, and this is basically like what should a wall do every frame. Right now, we don't really want walls to take any action every frame. We don't really have an action for them to take. Maybe later we will, but for now we don't. So I'm actually even going to just delete that. If we want it back later, we can always just add it. So if I delete it, that means that I'm no longer overriding the act method. If we look in the actor class, you'll see that the actor class has an act method, and this is the thing that we usually override, meaning we're going to make it do something different. If you actually clicked at the description here, it says that basically every frame, this method is called, okay? And the default implementation is to do nothing, okay? So it's kind of expecting you to override it, but you don't have to override it if you're not going to tell it to do anything. In that case, you might as well just get rid of it and just use the original implementation that does nothing. Okay, so that way we have only the code that we really need. And that's kind of the whole point of subclassing and making these class hierarchies, is that you write in the top level classes, you write a bunch of methods that control all the common behaviors and things that you need the class to do. So this actor class has like tons of methods. And then when we want to make a specific actor, we can focus only on what does this actor do differently, right? And so in this case, the main thing that actors generally do differently is they act differently, right? So the act method, like what do they do every frame, is different. Okay, but basically we can focus just on what's different. In this case, there's something important you need to know about how constructors work. If I just make a class like this and notice that I haven't declared any constructors, then what happens is that the compiler defines a constructor for me. This is called the default constructor, right? That's one of the reasons why it's called the default constructor. So basically, if I write nothing, the compiler writes this: public wall with no parameters, right? And then it also let's see, I'm gonna leave it at that for now. Okay, so it writes public wall with no parameters. Okay, so then in here, if I explicitly write it, I can actually add some extra code in here to set this actor up. If I don't write anything, if I just write this, then the compiler is just going to make a constructor that does nothing basically. But what I want is a constructor that's going to make every wall be the size that I want it to be. So you know what? I think I'm actually going to make that. I could actually make that a parameter here. So I could make this. You know what? No, I'm going to keep it simple. We're going to say every wall is 32 by 32. So I'm just going to make it 32 by 32. So that way we just focus on how to do that. Okay, so when you create a wall, normally it just creates an instance of the Greenfoot image that represents the image for this actor, right? If I want the image to be changed, then I need to get the Greenfoot image. Okay. So in this case, what I mean by changed is I'm going to take the actual original image and modify it in some way. Okay, that's different than if I wanted to take the image and if I wanted to like set it to a different image. Okay, so in this case, I want the Greenfoot image img equals and then if I just say get image, then that gets me the image of the wall, right? So then if I were to look at get image, you'll see that it returns a Greenfoot image. Okay, and if I were to click on this Greenfoot image, then I can see all the things that Greenfoot images can do. Okay, so down here, you'll see that there is a method here called scale, which is exactly what I want. I send it the width and height that I would like the actor to be, and it makes that actor be that width and height. Just so you know, it's gonna like stretch the image out if you make it be different, what's called aspect ratio. So like if it was a square image and then you turned it into a rectangle, then it would be like horizontally stretched. Okay, but I'm gonna keep this simple. This is actually already a square image, and I'm just gonna make the image be 32 by 32. So I can just say image.scale and just pass it 32 and 32. And now every time I make a new wall, it runs this code and it makes the walls 32 by 32. Okay, so now if I go back here, the walls are now more like what you saw when I was playing the game before, right? They're 32 by 32. But that also means that it now takes 20 walls to get across, right? So if I want 2 walls in the middle, then that means I need 9 walls on each side, right? So I can just update that and say I want it to be 9 walls. Okay. And then I also want another one on the right side here. So now that I've drawn this, made this helper method, this makes it super simple. I can just say, do another one, but this time, let's calculate actually. So comment that out for a second. Let's calculate where this should be. So essentially, this is 9 times width, right? Gets you to here, and then we want another width for this open spot. Okay, and then another width for another open spot. I'm basically going to make a open spot here equivalent to like two wall squares. Okay, and then that's where I want my next 9 wall segment to start, or that's where, okay, so if you count this, we got 9, 10, 11, so we can just make it 11 times. So this whole distance here is 11 times the width, right? Where, the 11 times the wall width, you could say. Okay, is all the way to here. Okay, so we could just write that for our X position. So let's go back here to my world. And it looks like we're gonna have to make another model wall, right? So right here, what I did here, where I wanted to like make a model wall and then get the width and height, I think that's also gonna be useful in here. So I'm actually gonna just do that same code here. I probably don't need the height, but I'm gonna leave it there for now. I might need it later. Probably when I do the vertical walls, I'm gonna need it. Okay, so then over here, we can say draw a horizontal wall, and then instead of at 0, 0, I want it to be at 11 times the wall width, but the Y is still gonna be 0, and I'm still making it a 9 length. Okay, let's take a look at that. Hey, there we go. Fits. I actually drew that just about perfectly. There, it fits perfectly in there. Okay, so then essentially, I want to do this entire thing again, just down here. Okay, same kind of setup, right? So we can use a lot of the same calculations, right? So the only difference here is the Y's are going to be different. Okay, so for the Y for this one, if we went all the way like world width, then we need to come back up wall width. Or sorry, whoops, holy smokes. Why did I say width? Height, world height. Okay, then I want to go up wall height. So hard to type. Okay, all right, I think you got the idea. So if I say world height minus wall height, then I get the right Y position, and then everything else is the same, right? I go, the first one is just going to be, the X position will be 0, right? And then for the second one, the X position will be 11 times wall width. Okay, let's do that. Okay, I think I'm going to delete all that because it's too hard to see what I'm typing. Okay, so we're going to basically copy this. I'm going to say this is like the top walls, and then this is going to be the bottom walls. And so then the first one, it starts at 0 for the X, but the height we said. So since we're in my world, then we can call the methods that world has, right? Including get height, right? So, and if I just say get height, it's the same as saying this dot get height, where this is the height of, this is the actual world I'm working in. Okay, so right here, I can just say get height, and then minus, we wanted to subtract the wall height. Okay, so again, if this was the canvas, we wanted to go all the way down here, which is get height, and then minus the wall height so that we're right here. Okay. And for the other wall, it's going to be the same Y position, but the X position is 11 times wall width, which is the same as what we did before. Okay, so I think we can just hit compile here, and there we go. We got mirror images on the top and bottom. Okay, and I'm gonna just do the same thing for vertical. So if we go here, we're gonna make this like almost the same. You know what? I kind of feel like we could just use the same method. You know what? I'm just gonna call this draw wall. Check this out. I'm gonna call this draw wall, and I'm just gonna have a Boolean that is like horizontal. And if it's horizontal, then it does what we just did here, right? If it's vertical, the only thing that's gonna change is instead of the X position changing, it'll just be the Y position that changes. So I'm gonna say this draws a wall. Why don't we just say this draws length wall tiles laid out horizontally or vertically, starting in the upper left corner of the leftmost or topmost wall tile at XY and extending to the right or down. Okay, so then how we would modify this is the starting point is going to be the same. The difference is we just have to have an if statement here to decide, are we going to keep changing the X or the Y, right? Because let's draw a picture just so you understand here. So if it was horizontal, then each time I draw the next X position, or each time I draw the next square, I have to move the X position by the width, right? But if these are vertical, then we're going to start at the top, and then we're just going to keep changing the Y position, and the X position stays the same, right? And the Y position is changing by the height. Okay, so this is like the wall height. Wow, hard to type. Okay, wall height. Okay, so then in here, I can just say if it's horizontal, okay, or if I write if horizontal equal true, this is the same as just saying if horizontal, right? Because horizontal will be true when it's true, right? When it equals true, and false when it equals false. So we can just say if horizontal, because it's actually a Boolean already. Okay, so if it's horizontal, then we do what we did before, okay? Otherwise, right, so else, we're gonna say wall Y plus equals wall height. Okay, so isn't this awesome? We just made one method that can actually draw all the walls rather than having to like copy this whole method and make a method that was like almost the same, except this is, except for this part, right? So that's what you want to always look for, those situations when you're coding where something is like almost the same, there's just like one part that's different. And if it's different in a very definable way, like then you could just modify the method to be more generalized. Okay, so let's try this. So that means on all of these horizontal walls, we're gonna say draw wall and we pass it true because they're horizontal. Okay, but then for the vertical walls, so just to confirm that works, right? See, this does the same thing. Okay, for the vertical walls, we just need to pass false. Okay, so that makes this super simple. We want the first vertical wall to appear here because I'm not going to make them overlap. And so that means, let's figure out this. So this was, so we had a 640 by 320. So if it's 320 this way, let me guarantee, double check that, right? Oh, sorry, 480, 640 by 480. I thought that sounded wrong. Okay, so 480 this way. If we do 480 divided by 32, let's see, so 10 would be 320, right? We got another 16, so that's another, so if we had another, okay, so this would be times 10, right? And this would be times 5, so that would be 15, right? So if we did 15 times 320, sorry, 15 times 32, right? That would be 320 plus 160, which would be 480. Okay, so therefore this is 15 squares. And when we did this one, we made the gaps size 2. Let's make this one have the gaps be size 3 instead. So there's like a size 3 gap in the middle here, right? And so then if there's 3 missing in the middle, the reason I'm going to do that is because 15 is an odd number. So I want it to work out to the same amount of squares above and below the gap. So this is going to be 3 in the middle, which leaves 12. So then each of these is going to be 6, right? So this will be like 6 walls high, and this will be 6, and then this will be 3 in the middle. Okay, so start at this position, which looks like it's just wall width, wall height, right? So 1 wall height, and then 0. And then this one is going to start at 6 plus 3, or 9 wall height, and also 0 for the X. Okay, and they're both length 6. Okay, that should be simple to write. Actually, I'm going to move this over here so you can see. Let's see, I'll just erase all this. Okay, so then I can say draw a wall, and I want we'll do the top one first. So it's going to start at wall height. Yep, see, these wall height calculations came in handy with my model. Okay, so I'm starting at wall height. Whoops, sorry. We want X to be 0, Y to be wall height. Okay. And then what's the length of the wall? Should be 6. And then these ones we want to be not horizontal, which will mean they're vertical. So we pass false. Okay. And then we want the second one. These are all going to start at 0 for X. The second one is we're doing 6 plus another 3, so that's 9 times the wall height. And still length 6 and 0 here. Okay, pretty straightforward. Okay, let's actually just confirm that that works. Okay, oh, there we go. Let's see. So wait, I miscalculated one thing here. The 6 and the 6 here should have been all the way to the edge, which means we actually should have subtracted 1 here and here. So this is actually 5 and 5, right? So we get 10, 13, and then there's 1 and 1 makes 15. Okay, well, that's pretty simple to fix. We just go back here. And change this to, okay, because what you'll see here is that it's not centered. The gap is not centered because it's only gap 2, and this wall, because it worked out wrong, like actually goes into this other wall. If you're wondering what actually happened. Okay, what it's showing there. So that's pretty simple. We just change these to 5s. There we go. And now we've got our perfectly centered gap 3 on the left and right side. Okay, so then we just do the same thing on the right side. Okay, so copy this, lay this out. We've got, okay, so for these ones, we want the X's to be different, right? Because it's the upper left corner. So this X it's similar to what we did when we did like height minus the wall height. So we're going to do width minus the wall width. And then the Y values are going to be the same, right? Okay, so the only difference is the X, instead of the X's being zeros, they're going to keep being the width of the world minus the wall width. Okay, so basically we can just say here, this will be the get width of the world, right? Minus wall width. That's going to be the same for both of these. Okay, so if we compile that, boom, we got the other side. All right, so we've laid out the outer walls. And then there was one wall, there was a giant wall in the middle here. So what we could do there is, let's just make it, let's just kind of guesstimate here. So this looks like it would be like 4 by 4 maybe. Okay, so if it was like 4 by 4, then okay, so then we could just kind of treat it like a single image and just like put it in the, if we wanted to put it in the center, then, okay, so if we want that centered, then the upper left corner of this row, so let's figure out where the upper left corner of this top row would be, and then we've got a starting point, right? So we want this XY. So then that would be, if we were at this, if the center was right here, then we'd want to go up 2 wall widths, right? And then right, sorry, and then left 2, oh, sorry, whoops, wall heights. I think it works out to the same thing, but let's make it accurate here. Okay, 2 wall heights and then 2 wall widths. Okay, so if we just went to the center of the canvas and then just went up and left, then we'd be good. Okay, so let's do that. So I'm going to say this is like top left of center block equals, yeah, all right. Top left of center block. It's kind of a long variable name, but it's okay. You know what? I'm just going to write center block X. That's what I'll call it. Center block X is, we go to the middle of the world. So get width divided by 2. And then we said we were going to go minus 2 wall widths, right? 2 wall W. Okay. And then for the center block Y, we want to go get height over 2 minus 2 times wall height. Okay, so then that would be where we'd want to draw, if we were doing the top row like this, we want the top row to be made up of 4. So we're going to say draw wall. We want the XY to be center block X, center block Y. And then we want the width to be 9, the length to be 4. Why did I say 9? We want it to be 4 wide, right? 4 blocks wide. And we want it to be horizontal, so true. Okay, and if we just did this, if we just did that 4 times, right? Just think of it as 4 rows of 4, then we've got our square, right? So why don't we just put this in a loop? For int I equals 0, I less than 4. We can just draw a row of 4, and we probably could have approached it as 4 columns. That would have worked too, but we're doing 4 rows, so they're horizontal. And then each time we do a row, we need to go to the next one, right? So it's kind of similar to what we did when we drew a column, right? A vertical wall. Each time we need to change the y to the next value, right? So I'm going to call this, I'm going to say center block y plus equals wall height. So then the first one, let's do stars. So the first one will be here, and then we increase y by wall height, right? Increase wall by wall height, increase wall by wall height. Okay, each time we draw a wall. Okay, so if we do that, then we've got our center all set up. Perfect. Okay, so now we just need to lay out some coins. Okay, so for the coins, we're going to say new subclass. We choose coin here. We call it a coin. All right. And then in the coin class, there's actually going to be some similarity in how we lay out these coins. It's going to be similar to what we did with the walls here. Okay, so I could do, let's see. So we could actually generalize this further. Okay, because right now we have a thing that draws either vertical or horizontal walls. We could make it have the same code, but it could have like another parameter, which is like what type of object is it gonna draw rows or columns of. So if we wanted it to make it super generalized, that would get into some advanced topics that I don't want to get into it at the moment. So I think what I'm going to do is I'm just going to make it so that it can either make rows of coins or columns of coins, or rows of walls or columns of walls, right? So right now we have like a Boolean that's like horizontal. Probably the simplest, since we're only gonna have two things that we can do in this game. I'm actually I'm gonna make a decision that would reduce the expansion of this later, but it makes it simpler, which is I'm just gonna make another Boolean that says like is wall. Okay, and is wall, if it's a wall, then I make a wall, right? Otherwise, I make a coin. Okay, so to do that, all that's going to do is it's going to affect the objects I make here, right? So there's a top level object, actor, and coins and walls are both types of actors. So what I could do is I could make the model be an actor. So I can say actor model. Okay. Oh, and there's one other thing. Wait, before we get into this, there was one other thing that I wanted to do. Let's see. Okay, let's consider this. So the other thing about the coins is in the original game, you may have noticed that the coins were actually not like right up against each other. There was like gaps between them. And so if we wanted to support that, I think let's see, then we would need to pass like a grid size that would represent like how big is each grid that each of these actors is centered in. And so in the case of the wall, we would just, the grid size would be the same as the wall size. But for the coins would be less. I think for the, you know what, I think for simplicity, I think we're just gonna lay these coins out and not worry about them being spaced out. You know what, I'm just gonna do that. I don't want this demo to take too long. So, and I think that's getting too deep there. Okay, so I mean, you could definitely figure that out. I think it would be a good challenge for you guys to try on your own. But I think we're gonna leave this to just, we have either walls or coins, and they're always laid out right up next to each other. Okay, So that means that instead of the wall being, instead of each model being a wall, the model is going to be an actor, because an actor is a more general type that we can store. If we make a variable of type actor, it can hold coins or it can hold walls, because both coins and actors, both coins and walls are types of actors. Okay, so I'm going to say actor model. Okay, and then I can say if is wall, then, and I get rid of this declaration, I initialize the model to a new wall, right? Otherwise, I make the model a new coin. And I can change this, let's see, I would probably want to change this to say model width. Actually, if you want to do something like that, like you want this variable to change, you can say Control F while it's selected and it'll fill this in for you. Otherwise, you just type it here. And then if you hit the little replace button here, you can say find all the wall W's and change them into model W's, right? And make sure you hit probably like match case so that it's going to find them exactly. You could just go on faith and just hit all, but I usually like to see what it's doing one at a time to make sure it's not replacing inappropriate ones, like things that aren't really what I wanted. Like anyway, so I'm gonna hit once there, once there. You can still go pretty quickly. And I actually am gonna go ahead and do it up here as well. Let me see, you know what? No, I'm not gonna change it up here because these really are walls. Okay, so I'm just gonna change it in here. And then the same thing here with wall height. It's really now more generally like model height. So I'm just gonna replace those, that one and that one. Okay, and then I'm not gonna replace any of the ones in here. Okay, just the ones in this method. Okay, so now I've generalized it even more. So now we're making a grid of either walls or coins. If you wanted to expand this, like let's say there was like 3 or 4 different types of actors that it could be, then you could actually, instead of a Boolean here, I would probably use like a string that says like the type of class that it is. Or the way that I was thinking of doing it that would be like the ultimate generalization would be to do what Greenfoot does, where it takes a class object here, right? And then you would pass like wall.class. But I don't really want to get into like how to do things with the class because I think it gets into too much complication. Okay, so this was definitely good enough for our purposes. Okay, so if it's a wall, we make a model wall. Otherwise, we make a model coin. Then we can get the width and height of whatever type of model it is. And then we also need to make sure that instead of making a bunch of walls, we make a bunch of whatever type we're supposed to make, right? So basically, we also make this one be an actor. I'll just call it object since it's now, it could be actually, yeah, let's make it object because this could be a wall or it could be a coin, right? So we declare it, and then if is wall, then we make the object be a new wall. Otherwise, we make the object be a new coin. All right, and this is a perfect use of the fact, this is a perfect use of in of a class hierarchy where you've got this higher level class actor, and then these things are both actors. So we can do things, we can make a method that can do the same kinds of things with either one of them, right? And then that's, if you remember, add object takes an actor. So passing it obj, since obj is an actor, works just fine. We don't have to know whether obj is a coin or a wall when we add it. We just know it's some kind of actor. It could be a coin or it could be a wall. Okay, and then the wx and wy, I'm just going to leave that the same. I'm not going to change all the things. Okay, and then everything else should be the same. Okay, so then to use this more generalized function, we're going to go back to calling this like draw row of actors. I think that's a good, let's see, oh, but it could be like horizontal, or why don't we call this draw line of actors, right? Because it could be like a row or it could be a column. All right, that's good enough. So then we just need to go up here, and we could probably do the same thing here that we did before. We find all the draw walls and change them into draw line of actors. So replace that one. I think probably I could have said all on this one, because I think anytime we said draw wall, we're always going to want it to be this. Okay, but then for all these times when we actually are drawing a wall, you remember that we had another parameter that was like, is it a wall? We want to pass true. So I'm going to just add that to each of these. So we need to pass that extra parameter. Okay. So if I hit compile now, yay, it does exactly the same thing, except now we have the option to do it for coins. Okay, so then in here, I've drawn all the walls. So this is like draw center block. Okay, now I'm going to draw a grid of coins. Okay, and this is actually going to be similar to what I did here. Where we figure out, I kind of feel like, you know what, let's take this and make it a method. Okay, so basically we're going to say public void draw rect of actors. Okay, and it's going to take an X and a Y for the upper left corner of the rectangle. And then it's going to take the same parameters as this, except it'll be like width and height, and then horizontal and is wall. So width, height, Boolean is wall, is, oh, no, wait, whoops, sorry. This one was horizontal, and this one is wall. Okay. By the way, if a line gets too long, I mean, this one we could probably just expand, but if the line gets too long, you can always break it like this and just, I usually like tab it over a bit. But in this case, I think if we just expand that, it's fine. Okay. All right. So then we're going to paste in what we did here. Okay, actually, these calculations are just calculating what we're going to pass for X and Y. So I'm going to put these back up here. But then in here, what we need, oh yeah, so we need the model, right? So we pretty much like need all this. It's actually gonna be very similar to what we did up here. Okay. So we need the model, and then we're gonna need to calculate let's see. Oh, we don't actually need this. Because X and Y are the actual upper left corners of each row that we want to pass, right? Okay, so here for the first one, we would just pass X, Y, right? Because if we were to, if we want this block, then X, Y actually is like the place we want up here to draw like this row of blocks. Okay, because we're gonna call draw line of actors. We pass it X, Y, and then we're gonna do so the length of each of these rows is gonna be the width, right? Because we're passing it the width, and we're gonna do it height number of times, right? Because that's how many rows there's gonna be, right? So we'll draw this, each row will be some width. We draw, whoops, just terrible. Each row will be some width. And we're gonna draw, like if there was height was 3, we would draw 3 of these rows, right? Where each row would be some width. Okay, and then each time we do a new row, we need to increase the Y value by the model height. That's it. Okay, so then, right, we would draw the first one here, and then the next row, actually, to be clear, we draw the first row here, right? Because each row is the upper left corner, and then the next row here, and the next row here. Okay, because it already took care of, if we pass it this for the row, then each of the images is gonna actually be here, right? It's already taking care of centering the images. That was taken care of in the draw row, draw line of actors, right? That's already taken care of. Okay, so that's all we need to do. So then we could just call this method up here, and we want to pass it the center X, right? And the center block Y. Those were the upper left corners of the center block. And then we wanted the center block to be 4 by 4. And it's going to be horizontal because we're going to pass it. Wait, why is there even a wait, let's go back here. We don't need this. Why would it need to be horizontal? Because we're always drawing this made up of rows, right? Oh yeah, and we didn't even use horizontal, of course, because we didn't need to. Okay. Get rid of that. And we want it to be a wall. There we go. Okay. So now we've got draw rect of actors. So this is going to be super simple now to draw a rect of coins. We just need to figure out where we want it, and then we just draw this method, and it takes care of it for us. Okay. So let's go back here. Actually, just to confirm that that all worked. Check it out. Yay, nothing changed. Okay, so now, but now we have this more generalized method. So I'm going to keep using kind of this grid somewhat, although the coins I think are not. Well, we could, you know what? We could make the coins 64 by 64. So if you remember when we did the walls, we did this, like we made each one 32 by 32. Sorry, not 64 by 64. We could just go to the coins here and just do the same thing, right? So for now, we're not going to have any actions here. We just have a constructor. And by the way, I just pressed Control-Shift-I and it fixes the indentation. It's also up here, edit, auto layout. It's pretty nice. Okay, but we want this to be, when we make a constructor, it has to match the class name, right? So this would be coin, but then the rest is the same, right? So we just make it a 32 by 32 coin. Okay, so that'll be nice because then we can use the same like grid logic that we did here. So we're gonna have, okay, so then this is just gonna be, yeah, this will make it super simple. So we just need to go 2 wall widths to the right or 2 coin widths to the right, however you want to say it, since it's gonna both be the same, and then 2 down, and then that's where we want our XY. And then we can probably estimate that this is like 1, 2, 3, 4, 5 across. And actually, remember this was like 15 and this was 20 in terms of 32 by 32 squares. So we could actually figure it out pretty exactly here. There's 2 up here. If we want to make it symmetrical, maybe go all the way down here so that there's 2 down here. So that leaves 11. So then this would be like 11 by, I'm just going to make this, actually, we can kind of see that this is like 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then -1, then -2 more. So that it is 5. Yeah, so we're gonna make this 5 by 11. Okay, so go back here. We're gonna do another draw row of actors, but this time it'll be coins, and it'll be 5 by 11, and it will be 2 times the wall width to the right, and 2 times wall height down, right? Oh wait, hold on. Is that right? Yeah. It was like 2 over, 2 over, and 2 down. Perfect. Okay. Let's see how that works. Oh, whoops. We made them walls though. Let's go back here. We just needed to pass. Hold on. This is supposed to be whether or not it's a wall. Ah, I got it. Okay, you know what? When we made this generalized, we have this parameter is wall, but then check it out. We always pass true. So we need to pass is wall so that it could be a wall or a coin. Let's do that. There we go. So we could have coins, we could have walls. Okay, so then let's just do the same thing on this side. And it's going to be pretty symmetrical. So, right, it's going to be width -2 and whoops, okay. So this is going to be width -2, 3, 4, 5, 6, 7. Okay, so that's going to be 7 this way, right? You can kind of like see where the squares are. Okay, so that gets us the x. So that's like, we could say this is like width -7 times wall width. And then it's just 2 times wall height for the y. All right, let's just do that. So we got here. So drawing the coins now is actually super simple because we already know how to draw rectangles. Okay, so we're doing a rectangle of coins, and this time it's going to be, we said it was going to be the width of the world minus 7 times wall width, and then it was going to be 2 times wall height for the Y, still going to be 5 by 11, and it won't be walls, so therefore it'll be coins. That's it. Compile it, and boom, we got our other coins. Okay, so that was all the setup. We now have all of that drawn, but we don't have any actions yet. Let's make the player now. So the player is going to be a big part of the actions. So we're going to say new subclass. You know what? Actually, hold on. I'm going to stop the video right here. We're going to say this is part 1 of the video, because I think this would be a good like break point. Okay, so let's do that. So I'm going to hit stop recording.